Hello there, and welcome to today's class. For this class, we're looking at the concept of load. All right, let's discuss the concept behind load, the definition, the types and the classes of load, and also how to abbreviate load in some concept. All right, let's dive into the concept of load. All right, let's start with definition of load. What is load by definition? A load is simply a force that acts on a structural member or a body if you want to. So I'm saying that a load is simply a force, right? It's an applied force on a structural member or on an object or on a body. So when a force or a weight or anything is applied on that thing, that thing that is applied is called said to be load. So if I have this phone here and I put this marker on it, this marker becomes a load to this phone. So that's the concept behind load. So a load is simply a force that acts on a structural member or on a body if you want to. All right, having discussed the definition of load, let's discuss something important called type of load. Let's discuss something important called types of load. When it comes to load, what are the various classes of it, types of load? When it comes to load, load can be classified in four ways. Number one there is called point load, or you call it concentrated. All right, number two there. Number one, we have the point load or concentrated load. That's the first type of load that we have. Number two there is that we have what we call the uniformly distributed load. Number three, when it comes to type of load, the second type of load that we have is called uniformly distributed load, also known as UDL. So when you hear the word UDL, we mean what? Uniformly distributed load. That's the second type of load that we have. The third type of load that we have is called uniformly varying load. So abbreviated as UVL. So when you hear the word UVL, we mean what? Uniformly varying load. So when it comes to type of load, we have point load, also called concentrated load. Number two, there we have uniformly distributed load, called UDL, if you want to. Number three, there we have uniformly varying load, that's UVL. And finally, number four, there we have what we called. All right. Before number 4 and 5, these are the three main fundamental type of load that we have: point load, UDL, and UVL. So aside this, I'll show you two more that exist. But note that these are the three major ones. So aside these three major ones, we have what we called the concentrated couple load. So we have the concentrated couple load if you want to. And finally, we have the distributed couple load. All right, these are the five types of load that we have. We said 1 to 3 are the major one. I just show you these two to show you that they exist. So we have concentrated couple load and we have distributed couple load. Let us call this load one after the other. Let's have the first one there called point load. All right, about one there. Point load. By definition, a point load is also called concentrated load. This is a type of load that acts at a point on a structural member. So whenever a load acts at a point, is said to be what? A point load. Load at a point. Point load. That's the concept. So when a load acts at a particular point on a structural member or on a body, is said to be what? The point load. So the diagrammatic expression for a point load is shown below. If I have a beam in this way, and I have a support here, and I have a support system here. So when it comes to point load, we said a load that what acts at a point. So this is called P. So note that load is abbreviated by the symbol P. All right. So P is represents load. All right. So this whenever you see something of this nature, this is referred to what? Point load. Load at the point. So in kilonewton, please. In kilonewton. All right. Here becomes the expression for point load. Let's dive into the second one. They're called uniformly Let's call the second one. They're called uniformly distributed load. By definition, uniformly distributed load is a type of load that acts through a distance or a length on a structural member. So when it comes to this uniformly distributed load, it's simply a load that is spread through a distance on a structural member. So that's like the concept behind uniformly distributed load. All right, the diagrammatic expression for this man here becomes something of this nature: a support here and a support here. So when it comes to UDL, yes, UDL, also called uniformly distributed load, the diagram is expressed in two cases. I'll give you the case 1 and the case 2. For the case 1 there, I have something of this nature. If I'm seeing this load, this is called uniformly distributed load. So this is one way of representing this type of load. The other diagrammatic expression, this case 1. For the case 2, I'll have a support system at this edge here and at this edge here. So when a beam is a load is in this form, it's said to be called uniformly distributed load. Note that the load is said to be P, as we said it earlier. This load here is called P, but what? In kilonewton per meter. This one here is called load. That's P in kilonewton per meter. All right, this is the concept behind the second type of load. Let's discuss the third type of load called uniformly varying load. All right, number 3. Let's discuss uniformly varying load. Uniformly varying load is a kind of load in form of triangle that acts on a structural member. So when I'm seeing a triangular load, now look up. When it comes to uniformly varying load, I'll be showing you one diagrammatic expression, but aside that one, there's other one there. We are saying that as I'll be giving you a diagrammatic expression for uniform varying load, just one. But note that aside from that one, other load, other diagrammatic expression for uniform varying load exists. So I'll be giving you the one of triangular load. So aside that triangular type of load of UVL, we have trapezoidal load, we have what's it called, triangular load, trapezoidal load, and parabolic load if you want to. So aside triangular load I'll be giving you now, there are other two more or three more. So let me just give you the diagrammatic expression for triangular load here. So I have a support system here, a support system here. All right. So have something of this nature. So this one here is a type of load. Is a form of what? Uniformly varying load. So the concept is that if I'm saying this type of load, the idea is simple. I'm talking about what the uniformly varying load. That's the concept, UVL. So these are the concept behind the three major type of load and their diagrammatic expression, as you can see. So of course, this is a load P measured in kilonewton per meter. All right. We said these two here are not that important, but they exist. So let me just show the diagram for concentric couple load and distributed couple load. For number 4 there, the diagrammatic expression for number 4 is something of this nature. This, whenever I see something of this nature, I'm telling you, these are just to show that they exist. That's why I put these two. So the diagrammatic expression for number 4 there, this one here is this one. Number 5 here becomes something of this nature. Number 5. So these are the concept behind these two type of load. All right, let's discuss other concept called classification of load, and we end today's class. All right, when it comes to classifying load, there are two distinct ways of classifying load. Number 1 there, we have what is called the live load. Perhaps let's start with dead load. We have the dead load, and number 2 there we have the live load. These are the two main type of load, classification of load that we have: dead load and what? And live load. All right, let's call this concept one after the other. For dead load, let's discuss the concept behind dead load. By definition, a dead load is a permanent load that is applied to a structure. So whenever when it comes to structure, any load that are permanent are said to be what? Dead load. So the concept is now that load. What are the examples of dead load? Number 1, there is beam. Beam is a load. True or false? It's very heavy. It's a kind of a heavier load, but what a permanent load. If you remove a beam in a structure, it will affect the structure. So that load is called a permanent load. It will be there. So such kind of load is called what? A dead load. So other example of dead load includes the weight of the structure itself. So like the wall, the floor, the roof, beam, column. So those are the example of dead load. Also know that dead load are called self-weight load. All right, know that dead load are called self-weight load. So I'm giving an example of dead load. Let's dive into the second one. They're called live load. Number 2, let's discuss live load and hence its concept. What's live load by definition? A live load is also called imposed load. So you only want imposed load. That's like the definition for live load. Imposed load is also used to represent live load. Either you hear the word imposed load or you hear the word live load. So I'm saying that imposed load or live load. I'm saying that live load is also called imposed load. This is the type of load that is temporary on structural member. So dead load are permanent, while live load are temporary. Example of live load includes people such as occupants, pedestrians. We have other one like furnitures and movable equipment. Those are like example of live load. We have vehicle, we have snow or rain load. So in some regions, right? So that these are the example of live loads and the concept behind dead load. In our next class, we'll be discussing about the computation of reaction and moment. So for that concept, you'll be learning how to find the reaction using the equation of static equilibrium to find reactions, right? So let's say I have something of this nature, a pin support and a roller support, and I have a uniform resisted load as this here, and I still have a point load. Let me call this one 6 kilonewton per meter. Let me call this one here 2 kilonewton, and I have from here to here is 5 meter, and from here to here let's say it's 2 meter, down here is 4 meter. If you want to assumption, please B A. So find the reaction of the support system. So look at this one here much more later in our next class. So see you in our next class. If our class helpful, do what you like, hit the subscription button, share to your friends and classmates so that they can learn too. See you in our next class once again. Bye.